Okay guys, remember to take good notes, pause whenever you need to, and write down whatever you would if you were taking notes in class, or maybe better. This section is the beginning of the second half of the year of calculus, the things that you learn. There's differential calculus, which is finding derivatives and all their applications, finding slopes, doing optimization, related rates, and so on, curve sketching. And then the other half is integral calculus. So this is going to be the beginning of that, and you're going to see one of the applications of integrals actually right away, which is that it will find areas under curves. Okay, let's take a look at one curve here, and I'm going to blow this up in a minute, but first read what I have. We're going to estimate the area under this curve, and we're going to use a number of rectangles to do it. What can you say about how many rectangles we might use? How accurate is our estimate going to be depending on how many rectangles we have? What would the width be? What would the length be? Let me blow these up a little bit for you to see. It might slant a little bit, that's okay. And I also want you to pay attention to the notation. I know it's getting a little bit blurry, but what I want you to see is that for the first one it says n equals 10, and when n equals 10, R10 is 0.385. When n equals 10, L10 is 0.285. You see one is higher, one is lower. The R and the L indicate what type of rectangles you have. R stands for right endpoint. So each one of these rectangles, and I'll do some of the higher ones because it's easier to see, each one of these rectangles, you can see how wide the base is down here. They all have the same width, okay? They all have the same length of their base. But as far as the height of each one of these rectangles, the height has to lie on the curve. So where do you want to find the height? Do you want to find it on the right side of the curve? That's what these are. Every rectangle has its height on the right side of the curve. Or down here, every rectangle touches the curve at its left side. So these are left endpoint rectangles. Now another thing to pay attention to is how good your estimate is depending on how many rectangles you have. So you have 10 rectangles there. Let me move this a little bit. And what you can probably see is that the higher the n gets, the closer these numbers are getting to one another. Look, this is only about 2/100ths apart right here. If we just look at the hundredths place, this is 0.32, this is 0.34, because we have 50 rectangles. Much closer together than the original two estimates. So again, the more rectangles, if you can see how far over you're going, or change colors, how far under you're going, that error gets to be less and less the more rectangles you have. Now this is more notation. This is just saying, it's actually defining area. So your area of the region S that lies under the graph of the continuous function f, and the function is going to be continuous, is the limit of the sum of the areas of the approximating rectangles. So in other words, let's just start at the end here. This is the width of one of the rectangles, and this is the height of the first rectangle. Here's the width of all the rectangles. This is the height of the second one. And then we go all the way up to the width of the nth rectangle, and then the height of the nth rectangle. So on the previous page, you saw 10 rectangles, 30 rectangles, 50 rectangles. So this would go up to, in the last one, say 50, right? But instead of actually stopping at a number, we're just going to take the limit. We're going to leave that last thing n, and we're going to take the limit of this as n approaches infinity, and then you could see how that would give us the exact area. The area of an infinite number of rectangles is going to give us an exact area. Okay, so for the next few examples, I have problems in Sophia for you in a Google form. So make sure that if you want to, you open that now and kind of watch this video and pause it, and then go answer some questions over there, or be able to come back to this specific page in the video and use it in these problems, the remaining ones here, to help you answer the questions in Sophia. Okay, right now you're going to need your calculator. What we're going to do, this is number 2 from your book, from Stewart. You want to use 6 rectangles to find estimates of each type for the area under the given graph. So in other words, we're trying to estimate this area. So now I guess I better pick a different color to draw my rectangles. So what we want to do is realize that between 0 and 12, we want to find or use 6 rectangles, and we want the heights to be left endpoints for this one, for Roman numeral 1. So the first thing I'm going to do is just kind of split this up. Now you know I'm going from 0 to 12, so it's probably kind of intuitive that each one of these rectangles is going to be 2 units wide. So I'm just going to sketch these in, and I'm only going to go up to the curve, and then I'll fill in the top parts of the rectangles in a minute. Now let's say this wasn't something super easy, like 0 to 12 being split up into 6. Let me just for a second say, what if you were going from, I don't know, -2 to 7, and you were splitting it up into 18 rectangles, or worse yet, like 10 rectangles. What you would want to do is figure out how wide is this interval, right? In this case, it's 9, and then divide it up into how many rectangles you have. Now, if you had 18 rectangles, each rectangle has a width of a half. If you had 10 rectangles, then each rectangle would have a length of 9/10 or 0.9. So in general, B, this is x equals B, this is x equals A. In general, to get the width of each rectangle, or to get your delta x, you would take B minus A and divide by n, how many rectangles you have. Alright, so back to this one. If I want to use left endpoints for the one that we're going to do together, then I want to start on the left side of each one of these rectangles, which means I'm going to start over here. And I'm going to go straight across, and that's my first rectangle. Then I'm going to start on the left side, go straight across, that's my next rectangle. And I'm going to start on the left side. Now again, all of these are intersecting the curve and the vertical line to the left of the rectangle. And by the time I'm done, I should have drawn 6 rectangles. I'm done, let me count. I have 1, 2, 3, 4, 5, 6. 6 rectangles. Okay, so now I'm going to estimate this going, my area is approximately equal to my Riemann sum, that's how you pronounce his name, Riemann sum, using left endpoints with 6 rectangles, is going to be, now I can go base times height plus base times height plus base times height. But notice that all of these bases, they're all the same length, right? Each one of these rectangles is the same width. So since the width is always 2, I can factor a 2 out, and then all I have to do is put in the heights. So the first height is 8 plus the next height, oh no it's not, it's 9. Okay, the next height is right about here. I don't know what I want to make it, so let's say 8.8 plus next one, here's my next height, maybe that's 8.2. Next height is, I'm going to guess 7.3. Now again, this is your estimate. You could choose whatever heights you want. This looks like it's a spot on 6. This also looks like it's right on 1, 2, 3, did I skip one? I had to have skipped one. Well, let me finish this out. So this was my 9. Let me do this so you guys can see where I'm pointing. This was my 9. This is my 8.8. This was my, what I was setting was 8.2. This is my 7.3. I didn't skip anything yet. This is my 6. And this will be my 4. Oh, I guess I just can't count. I didn't skip anything. Plus 4. So if I'm adding together the areas of 6 rectangles, I'm going to need 6 heights. 1, 2, 3, 4, 5, 6. All right, now I'm going to get my calculator and do this. Okay, and I got, oops, my pen. I got 86.6. Now, if you want to ballpark this, see if it's right. I don't know, give yourself some kind of a crazy overestimate, something like this. This would be what? 9 times 12? 9 times 12 would be 108. So minus this big chunk here, gives you 86.6. Sounds like a reasonable estimate, and it is. So I leave it to you now to do the right endpoints. Always be careful. Make sure you're getting 6 heights, and then you can factor out your one base, and then try midpoints. Let me just draw in here for a second a midpoint. I'm going to pause this, and I'm going to get rid of all of these annotations. Okay, you would know how to get right endpoints. Each rectangle would just start on the right and work its way to the left. I'm going to get rid of those. Now for midpoints, though, we haven't really even looked at any of those yet, so let me just help you with some midpoints. Again, you want to start out with the same process where you go ahead and put in all your widths of your rectangles, but now your heights are going to come from the middle. So between 10 and 12 is 11, so that's where I want my rectangle's height to be. Between 8 and 10 is 9, so I'm going to go to 9 on the curve. Between 6 and 8 is 7, so I'm going to be on the curve at 7, and so on. This is how you draw a midpoint Riemann sum, and again, I will leave the rest of this to you as far as what the heights are and what the base is. Okay, so for number 5, I'm going to hurry this up, so pause a lot if you need to. First thing that I want to do is sketch the curve. Now I have 1 plus x squared. You know what the shape of this is? Let's say this is 1. Okay, so if I want to estimate the area for this between -1 and 2 using 3 rectangles, at first my rectangles are going to be split like this. Let's do right endpoints. So here's a right endpoint, and here's a right endpoint, and here's a right endpoint. And then after that I'm going to use 6 rectangles. So then I'm going to have this one and this one. And then I'm going to have this one and this one. And this will probably be the easiest to see. And I'm going to have this one and this one. Now the difference between this and everything else is that to get these heights, you can actually use your calculator to get them. So I would suggest putting this in y1 and then doing y1 of 2. It's easy to put the integers in, but it might take you a little bit longer if you want to put in a negative a half, a 1.5, and so on. So that's why I would suggest putting that in there. And then whenever I'm going to get the 6 rectangle estimate, maybe I'll just do that because I don't want to go over 15 minutes here. I'm going to take my base length and factor it out, and then I'm going to get f of a negative a half plus f of 0 plus f of a half plus f of 1 plus f of 1.5 plus f of 2. And those are the heights of my 6 rectangles. 1 height, 2 heights, 3 heights, 4 heights, 5 heights, 6 heights. So sum those, multiply by the base, and you have your answer. Okay, I am down to like 50 seconds, so all I'm going to do is say, try this problem yourself before you watch the next video, because I will do this on the next video. And then here is your homework.